Alright, in this video I'm going to finish off solving this inverse Laplace transform. By the way, this minus 1/2 was correct. So let's keep going. So x of t is equal to 1/4 e to the minus t plus 1/4. Now this is going to be multiplied by the inverse Laplace transform. And I'm going to do two steps in this step. So I'm going to take this 3 out the front and factor out the highest common factor. And then this 2 here, this is the same as 7/4. Alright, so now x of t is equal to 1/4 e to the minus t plus 3/4 if I take this 3 out the front here. And that's multiplied by the inverse Laplace transform, but I'm going to do another step. And I'm going to split the inverse Laplace transforms. And this is going to be s over s minus 1/2 all squared plus 7/4. By the way, this is a really advanced inverse Laplace transform, really. This is probably the hardest you're going to get. And then that's plus 3 multiplied by the inverse Laplace transform of 1 over s minus 1/2 all squared plus 7/4. And then close the last big bracket. So then x of t is equal to 1/4 e to the minus t plus 3/4. Now I'm going to do a step here, and I have a minus 1/2 plus 1/2. And that doesn't change the value, right? And the reason why I'm doing that is I know I need this s minus 1/2 here, because that's the exact same as this. And that will give me e to the at cosine of bt. Sorry, I'm burping at the moment. Alright, so, and this plus 1/2 will be added to this. So 3 plus 1/2, 3 times 2 is 6, plus 1 is 7/2. So this is going to be, alright, the inverse Laplace transform of s minus 1/2 over s minus 1/2 squared plus 7/4. And then that's plus 7/2 multiplied by the inverse Laplace transform. And now I'm going to multiply top and bottom here by the square root of 7/2, because this is a b squared term and I need b here for this to be e to the at sine of bt. So multiply top and bottom, that is square root of 7/2, and likewise square root of 7/2, which is the square root of 7/2, square root of 7/2 over, that's a 2 there, I'm sorry, that's even worse actually. This is a 2, so s minus 1/2 all squared plus 7/4. Alright, so we're almost there. Now this 3/4 is going to be distributed. By the way, these 2's are going to cancel with each other. So this is actually the 7 over the square root of 7. But I'm going to rationalize the denominator because we don't usually keep square roots in the denominator. So this is going to be e to the 1/2 t cosine of the square root of 7/2t. And then that's plus, well, multiply top and bottom, this is going to be 7 square root 7 over 7, which is just the square root of 7. So, if I rationalize the 7 over the square root of 7, it's just going to be the square root of 7. And then that's going to be e to the 1/2t sine of the square root of 7/2t. And that's actually just our final answer right there. So as you can see, this is actually a really advanced inverse Laplace transform, and that's why this video for solving the Laplace transform to solve a second order differential equation took 3 parts. I apologize for that, but yeah, this could have been its very own video, this inverse Laplace transform. It's actually pretty tricky. But yeah, that's pretty much it Thanks for watching, and yeah.